All right. All right. So for this Search for Solutions project, we looked at hydrogen fuel cells. And so with hydrogen fuel cells, they work the same way as that of a battery. And you can see in this figure that they both have a cathode and an anode, and except that it doesn't produce any combustion or emissions, and which is one of the reasons why it's so sought after. And so they use chemical bonding from certain molecules, and they'll convert that into electrical energy. And since hydrogen gas is so abundant on Earth, it can be utilized in a pretty effective way. And so in the system, we have both hydrogen and oxygen coming into the system, and as a result, you're getting heat, electricity, and water that's coming out. And so this technology can be used in a lot of different industries. And so they're looking at the automotive industry and looking at hydrogen fuel cells in cars.
So how do hydrogen fuel cells work? Hydrogen fuel cells combine hydrogen and oxygen to create electricity through redox reactions. In a fuel cell, it is made out of a cathode and an anode with an electrolyte in between. The hydrogen enters through the anode and the oxygen enters through the cathode, and the electrolyte allows ions to move in between the cathode and the anode, while an external circuit is connected, which allows electrons to flow from the anode to the cathode through an external circuit, which creates the flow of electricity. The resulting reaction then creates heat and water as the byproducts.
All right, so basically, one of the main reasons why using hydrogen fuel cells actually matters is to combat global warming. So the ways that it affects global change issues is specifically that. We need fuel sources that are going to be both efficient and environmentally safe. So the use of hydrogen fuel cells can impact many different industries, such as transportation, large-scale power generation, heat generation, powering industry vehicles, a lot of things. And according to the Hydrogen Council, the use of hydrogen and hydrogen fuel cells is extremely important in order to keep us below the 2 degrees of average warming by 2050 that we need to stay alive on this planet. And what they specifically do is they don't burn fossil fuels, so it reduces the amount of CO2 emissions that contribute to the greenhouse effect. Okay, so what specifically are the benefits, right? So using hydrogen fuel cells in vehicles allows them to be more efficient because hydrogen as a fuel source is extremely energy dense when compared to other fuels such as gasoline. And so in other places, like when you're heating like a large scale like steel production or any other kind of reaction that needs heat, using hydrogen, burning hydrogen and using hydrogen fuel cells can allow you to generate that heat without generating so much of that CO2 that goes into the atmosphere. And luckily for us, hydrogen is one of the most abundant elements on Earth. So by integrating it into our pre-existing structure that we have for renewable energy, we can move away from fossil fuels more quickly. And economically speaking, the use of hydrogen fuel cells in that industry would create a large amount of jobs that can help ease the transition that from people that are in fossil fuel industries towards more renewable energy.
So what are some criticisms of using hydrogen fuel cells? Well, making, storing, and transporting hydrogen is pretty expensive, and there isn't enough infrastructure to really distribute it around the country. Since hydrogen needs like pressurized or really sturdy tanks to hold it, since it needs to be pressurized, and there's a chance that it could just like explode. Also, creating hydrogen requires energy to make it, and most of the energy that is created right now are from fossil fuels, which wouldn't be as environmentally friendly. Also, hydrogen is also made from fossil fuel. Hydrogen itself is also made from fossil fuels, so that also adds to its like not environmental friendliness. Fuel cells are also expensive to make because it requires expensive materials like platinum to make it for like the catalyst, and yeah.
All right, and so like what is required to accomplish it? So there's three main components. So we have the fuel cells, we have the generators, and then we have the alternative energy sources slash hydrogen. And so with fuel cells, so it'll only get down in price the more we scale up. And so when we do scale it up, the fuel cells will cost around $400 per kilowatt. And generators act in the same way. So when fuel cells are scaled up and the prices decrease, we'll see a decrease in generator costs. But I mean, currently in Spain, they said that 30% of like the generators for hydrogen cost 30% more than that of solar. So it doesn't make sense to implement it at this time. And then, as I mentioned earlier, a lot of the hydrogen comes from fossil fuel combustion. So like we have to find another source of hydrogen once we get rid of these hydrogen fuels. And then in the graph, we can see when we scale this up and we look at costs, we see that there's a higher energy output when we scale it up and have higher costs per hydrogen. And then as a summary, so we looked at fuel cells and how they use hydrogen to produce energy. And so they cut down on CO2 emissions and can be used in many different industries. However, it is a very costly system, and making and storing hydrogen can be pretty significant in costs. And then here are references.
Thank you.
Thank you.
Okay.